First of all, thank you for the organizing committee, Juliet, Federico, and the rest of the committee members for the opportunity to speak here. My presentation today is about new directions or new development in information organization. Specifically, I will talk about a linked data model with BIBFRAME. There are many ways to organize information, many standards, many procedures. And today, what I will do is talk about the latest development. First of all, RDA. Secondly, BIBFRAME. And then linked data model. RDA, BIBFRAME, and the linked data model, they are the three pieces to one puzzle. Basically, they are really very closely related. RDA will tell catalogers how to describe a resource, isolate data into small pieces, and then make it ready for linked data. BIBFRAME is a new bibliographic display standard which will replace MARC, maybe very soon. And then BIBFRAME is a linked data model. So in my presentation, I will talk about BIBFRAME first, then I will explain what is a linked data model. So basically, Eric Miller, the person in the picture, he is a developer who works with Library of Congress to develop this BIBFRAME. And he is an experienced researcher both in libraries and in semantic web. The progress can be monitored at www.bibframe.org. So what does BIBFRAME do actually? After RDA is being implemented, now we have to concentrate on BIBFRAME. The BIBFRAME will convert all the existing data from 40 years of MARC records into linked data formats. And it will also convert future cataloging into linked data formats. That's what BIBFRAME will do. So what do we know about BIBFRAME? First of all, it's a totally new bibliographic environment. AACR2 and MARC are old story. MARC is still being used, but this new BIBFRAME will give catalogers and librarians a totally new bibliographic environment. And secondly, it will take all the MARC records from the past 40 years and convert it into data that is ready for linking. And also it will take future data. For instance, in the future, we don't know what kind of data will appear. For instance, the new file format. Maybe tomorrow technology will invent some new formats, big data. So basically, this BIBFRAME will accommodate the future needs. And also it will be used by different communities, not only by libraries. Libraries is being called a memory organization. And the other memory organizations include archives, museums, publishers. And the big data and the wider range of communities may be able to use BIBFRAME as well. So it's designed for everybody, not only for memory organizations. So more on BIBFRAME. Basically, BIBFRAME is dealing with data elements. It's RDA will show the catalogers how to isolate data into small pieces, small building blocks, and each data element contains only one type of information. The reason we are doing this is because we need a machine to process the data. If you fit different data into one container, then machine cannot tell you what is what. So dividing data into small pieces as small building blocks is the first step. And secondly, these small pieces of data can be recombined and reused in any way a community is interested in. For instance, in the future, the Wall Street companies, they like this data. They can grab small pieces and only grab the small pieces that are useful for them. And then they will build data, small data, into bigger blocks of data. If you know, in America, probably in the world, people are selling toys called Legos. And Legos are small pieces. You can buy Legos from different toy shops. Still, you can combine them into different shapes. So these BIBFRAME data elements are like Legos. You can combine and recombine and reuse because RDA is teaching us how to catalog into small data. And also, this BIBFRAME will accommodate different community profiles. All the memory organizations, in addition industries or anybody who care to use this BIBFRAME. And the BIBFRAME will connect the data through different communities and link them in a meaningful way. This is a value-added process because you are building different shapes which are interesting to different communities through small data. So it's a value-added process, basically. You are creating new data with new meaning for new communities. And data is reusable. This is supposed to be part of the web. It's not on the web. There's a difference. One, as users, we don't see the difference, but as technical people, they can see the difference. Part of the web, not on the web. Okay, a BIBFRAME structure. In BIBFRAME, we have some structures. The first class of objects is work. It's like a RDA kind of semantic RDA relationship, entity relationship. The first work is creative work. It's an intellectual piece of work. And then, secondly, instances. Basically, an instance is a physical or intellectual work in the embodiment of a physical embodiment or material embodiment of the intellectual work. And then we have authority. Authority behaves like authority in current cataloging. And finally, we have annotation. Annotation basically is data for the local libraries. Users can add review to the library data, and also libraries should enter their holdings information, cover art, book cover, that kind of stuff. So this is a picture taken from a BIBFRAME website. Basically, this is very clear. In the middle, what did I do? In the middle, this part is the intellectual work. Then you have an instance, and then this is the picture. Work, instance. Then in instance, you have publisher, a publication place, format, and these are all in authority file, so-called authority file. And the creator, the author, is also from authority, and subject from authority. So this is very much like further relationship, similar. And then we add annotation from local level. So annotation, basically, annotation will be the review of this intellectual work. And also annotation can happen in the instance also. And the annotation will add local holding, and local holding will attach, the institution will attach to this local annotation. And the people in the BIBFRAME, maybe we will allow users to enter data in the future. So linked data, BIBFRAME, the presentation about BIBFRAME is finished. Basically, this is still under development. You can monitor the progress of this development on their website. And they do have agenda. They try to develop it as fast as they can so people don't have to use MARC. So linked data, I will go over some basic concepts about linked data. Linked data is a term to describe a recommended best practice to exposing, sharing, connecting pieces of data, information, and knowledge on the semantic web using URIs and RDF. So URIs and RDF are not familiar concepts for librarians at all. They are very strange to librarians. So maybe we should take a look at what is RDF and URI. This man here, he is the head of a board governing internet. His name is Tim Berners-Lee. He's famous in semantic web. So semantic web is based on linked data. They are more or less the same thing. So basically, he has this idea about linked data and semantic web about 10 years ago. And the semantic web or linked data has different names. It's also called Web 3.0. And this semantic web or linked data is not going to replace internet. Instead, it's going to be an enhancement or extension for the internet. So linked data is basically we are linking data through the web, not the documents. Right now, the web is linking HTML documents. We jump from documents to documents. But in reality, when we link the data, we really are seeing a web page with data assembled from different sources. So there are three things you need to remember about linked data or the semantic web. The first thing you should remember is machine understand process data. As I told you before, RDA is telling the catalog to isolate data into small pieces as the most basic building block for the semantic web and linked data. That's why we have RDA, not RACR2 anymore. And secondly, linked data is about entity relationships. RDA is also about entity relationships. Basically, we are trying to look at objects and then describe their property attributes and establish relationship between objects. So the reason we want to use URI, remember at the beginning they talked about URI in the linked data. A URI actually is a web address. Why do we want to use URI? If we talk about Boston, for instance, if someone says, I love Boston here, right? There are 26 Bostons on the web. You have to use human eyes to distinguish which one. Then, if we talk about UC Berkeley, there are 50 ways people write UC Berkeley. So, basically, when you talk about Boston, you are talking about one particular entity. So we are talking about a single entity. When we talk about single entity, then we realize probably we can use a resource to represent an entity. So, because spelling, entity, text have different meanings and also have different spellings, it's hard for machines to distinguish. But if you have a resource, then machine can tell the difference. So that's why we use URI. Each URI represents a resource on the web, identity. So uniform resource identifier is called URI. A URI is a resource on the internet which represents an identity. It's not it's very clear what a Boston, which Boston, and which UC Berkeley. So entity on the web is a resource. We call it a resource, and it's represented by a unique URI. The examples I can't show you because I have to come here press. Basically, example of URI is Shakespeare. It's in the Library of Congress subject heading. It's represented by a URI. 911 terrorist attacks is another URI. It's represented by a URI. So URI is the most important building block in the linked data. So Library of Congress, they develop a subject heading into URIs. The more URIs you have, the more linking we will have. So next, the important building block in linked data is this structure, is this sentence, subject, predicate, and object. The subject has to be a URI, predicate has to be a URI, object can be a URI, can be text. The more URI you use to fit into this structure, the more linking you will have. If you use text in the structure, then linking will not happen. So this is the basic structure for linked data. So this linked data structure has a different name. It's called RDF Triples. As librarians, you will hear more and more about RDF, about linked data, about URI, because BIBFRAME, all BIBFRAME is trying to do is to convert MARC records into RDF statements. That's all it does. Nothing more, nothing less. So these are the examples of subject, predicate, and object. New York can be a subject. Its place of publication of. This is also a URI. This can be a URI. And then Renty County, this is the name of a book. It can be another URI because you can have a web page which describes Renty County, which is a resource also. So in all the three parts, they can be represented by three URIs. And the more URIs you have, the more triples you have, the more linking you will have. So this is a typical code written in probably RDF XML. And this RDF XML is the most common language to write RDF statement. Again, BIBFRAME is trying to convert all the MARC records into such statements. That's what we are trying to do. So originally, library data or anyone's data, they are in hidden web, in a silo, in an isolated place. So in order to share data and everything, we need to share ontologies and vocabularies. If we have a common vocabulary and ontology, then those databases can have a common base to talk to each other. That's the basic idea. Again, now we come back to vocabulary and ontology. This is another new concept in the semantic web linked data. Ontology basically is a definition of relationships. For instance, education may have an ontology for education. In the ontology, you have to define the relationship between the class and the students, relationship between professor and the students, relationship between the president and the professors, relationship between library and the faculty. So ontology basically is a file that will define relationships, and vocabularies are controlled vocabulary that will be also used as labels when you do the RDF statement. So semantic web ontologies. Basically, each subject domain, like biology, has their own ontology to define their relationships, and the library should have their own ontologies, and then chemistry has their own. So as librarians, we should go out and use other people's ontology. In return, other people should come back to use library's ontology. This way, we will merge into the linked data world, be part of the big linked data community. So this is some finished ontologies by other communities, not by librarians. Libraries are developing their own ontologies and vocabularies. This is a listing ontologies by other different fields. For instance, they have a friend of a friend, a friend of a friend. This ontology defines people's relationship between friends. You are my friend, I'm his friend. Then eventually they begin to link. Then through me, they may know each other. So they define personal relationship. This is a famous ontology and project for semantic web and linking data. So what do we really want? What do we really want is, first of all, convert, get all the big data in RDF statements. That's what we are trying to do right now. And also, we have to link them by entity relationships and share vocabularies and ontologies with other communities and be part of the semantic web, not in the library silo. Otherwise, librarians always keep to ourselves, use our own subject heading, use our own vocabulary. If we can get other people use our own vocabulary and subject heading, then we are one step towards linking with other people. Okay, these are the examples of successful semantic web applications. Librarians are not sure about semantic web so far because there are not many successful examples. I do recommend you to take a look at OCOC WordCat. They have a experimental semantic web element in their WordCat. When you look at their record is not only from the big data, it also pulls data from internet, Wikipedia, and different places. So about a particular author, you may have review about her, Wikipedia information, a lot of other stuff, his own web page. So miscellaneous sources on the web are assembled together through linked data into the big records. So basically, this is a picture of headache. What problem do we face now? The most challenge for this linked data probably lies in converting existing MARC records into whatever RDF statements. The reason is MARC in the same field, like mark is marked by numbers, 240, 245 is title, but sometimes catalogers over the years may put other data into that field. So it's really hard for machine to isolate them. And in addition, we have mass of data. We can't go back and recatalog them. So this might be a challenge for the BIBFRAME to translate the old data, existing mark, into RDF statement. With the new data, we can design program and catalog will enter data and convert that data into RDF statement. But with old mark, it's a huge challenge. So thank you very much for listening to my presentation. If you have any questions, if we don't have time here, you can send me an email. My email is here. Thank you very much.